In this video, we're going to look at unit goal 2 for our system of equations and matrices unit. Basically, we're going to look at the matrices part. What is a matrix? So unit goal 2 says we're going to be able to solve a system of equations using a matrix. So we need to talk about what a matrix is. And now a matrix can be used for a lot more than just solving a system of equations, but solving systems of equations is a good introduction to what matrices do. Basically, where would you see these things? Well, if you go into any kind of higher math in college, typically these appear in different places. So if you're going to college and got to take some math, or you're going on in some kind of technical subject, it's good to know that these things exist because a matrix is able to solve a lot of different problems. If you're not going right on to college, but you're a junior and you're going to take like an AP course, AP statistics, which uses a lot of data arrays, there's a couple things that we can use a matrix for. So matrices are usually used, like I said, in higher math, but they're actually kind of a simple thing, and the big thing is they allow us to interface with technology and allow the technology to do a lot of the work for us. So basically, a matrix is going to be a useful tool for many different things, but in this course, we're just doing an introduction. So we'll just introduce what it is through thinking of it like a system of equations. All right, so let's see what is a matrix and how does it solve a system of equations for us. Basically, I'm going to show how to turn it into this, and then the technology will do the work for us, meaning a calculator. All right, so what is a matrix? A matrix is just an array of numbers. For us, they're going to be typically the coefficients of a system of equations, but once again, any kind of array of numbers can be put in a matrix. So if you had like a table of values, you had like several rows, several columns, things like that. So what is a matrix? It's this thing on the right. Basically, it's an array of numbers. Now, on the left, I have the system of equations associated with it. So when we look at systems of equations, it had two variables. We needed two equations and had these extra answers. When we solve the system of equations by elimination, all we really do is manipulate the numbers that are on all these things. We don't really change the fact that there are x's and that we get an x answer. We don't really change the fact there are y's and we get a y answer. And we definitely get some kind of numerical output. So the thing is that the x's, the y's, and the fact there are numbers over here, they're not really as important as what's happening with the combinations of numbers. So basically, I don't really need to write the x's and the y's so long as everything's lined up. So what the matrix does is it takes off those coefficients and ignores the variables. So what I have here is just the numbers, the 4, the 3, the -1. Notice this has 4, 3, -1. This has 2, 5, 3, and this has 2, 5, 3. It is important to make sure that before you make the matrix that the variables do need to be lined up and the constants need to be lined up. You can't have this be an x and this be a y. So you want to make sure that the equations are arranged so that there's like an x column, a y column, if there's another one, a z column, or however many variables you have, and that there's an answer column with the constants in it. But once you do that, the way you make a matrix out is you just make an array of the numbers, and since there were 2 rows and 3 essential columns here, I get a matrix that's 2 rows and 3 columns. And now matrices can really be any rectangular size. You can have a matrix with, now, like I said, there are rows to them and columns to them. This one is 2 rows and 3 columns. You can have them be any number of rows or any number of columns. Now, when we're solving systems of equations, we're usually going to have, however, the number of rows we'll have will be the number of variables, and we'll have one extra column for the answers. So if this had 3 variables, if it was x, y, z, and a set of numbers, we would need 3 equations. So if I had 3 variables, this would actually, I could make a 3x4 matrix that would represent this. Now, this little line here, you don't actually have to put. In an actual matrix, they don't put this little bar here. The reason I have the little bar there, it's kind of an optional thing. It's just to see the separation between the variables and the constants. So constants just being the numbers. So these are the coefficients of variables. These are just numbers in themselves. So when you solve them with system of equations, sometimes they put this little line here just to make that separation. But this line's kind of artificial. Like in a matrix, when you see a matrix written, they don't have to put a line between them. They could just put 3 numbers up top and 3 numbers on the bottom. All right. So the important things to get out of this is that the system of equations can have its numbers peeled off and put in this matrix format. These brackets around the array of numbers show that it's a matrix. So it's like the symbol, look, I'm making a matrix out of these numbers. Like I said, this line is optional. And so long as you load a bunch of numbers into this rectangular grid, you've made a matrix out of it. Now, the question then is, well, what does this do for us? How do we solve this and how do we get answers? So due to time constraints and the fact that we're not in class, it's a little time consuming to talk about how we solve this. The thing is, when we solved the system of equations, we had to do elimination. The rules of elimination are basically the rules of manipulating a matrix, and there are ways to turn this into the answers. Now, since it's complicated to go through all of that and show you how to solve the matrix by hand, because in the end, someone shows you how to solve the matrix by hand and then just tells you to use technology to do it. So due to our constraints of this online teaching, I'm not going to show the steps of how you solve the matrix. But in case someone you do ever encounter it, basically all the rules that you can do in here, where you can multiply things and add things and cancel them and stuff, you can do them in this array of numbers. The difference is when you work with this, you basically eventually get it down to just x equals or y equals. When you work with the matrix, you always keep it as a 2 by 3 array of numbers. So like the matrix never shrinks or grows. It's always this size. And basically someone's manipulating the numbers in here to be equivalent matrices until they get to the answer. So the important thing, if we're going to use technologies, you have to know what the answer will look like. So if somebody solves this, how do they know what the values of x and y are? Because basically what I'm telling you is the technology will do this a lot faster and give you the values of x and y. It's going to basically give it in a format that's a little different than what you do over here. So I'm going to show what the final form looks like. The matrix that will give you the answer is in a form called reduced row echelon form. So basically the matrix can be manipulated into this form if it has answers. Now what does this form look like? I'm not going to show the answer matrix to this yet. I'm going to show a larger matrix to just kind of give the point of what this form looks like. All right, so what is this reduced row echelon form? Well, remember, this is not the matrix I was just working with. I just made this up because it's a little bigger. Because basically, reduced row echelon form for a matrix, abbreviate RREF. So when you go to look in a calculator or elsewhere for this, this is its abbreviation. Reduced row echelon form is basically having ones on the diagonal, and namely, a 1 in the upper left of diagonal spot, and then a 1 in every diagonal until you get to the bottom right corner of this square section. That's why I have the line here. You should have all ones on the diagonal and zeros everywhere else, except the answer column. Because basically, once it's in this form, if you kind of understand that this was representing the x's, and this was representing the y's, and this is representing the answer column, this is representing that there's 4x plus 3y equals -1, and that 2x plus 5y was equaling 3. Well, for this matrix, now this would be a 3-variable matrix. This would have an x column, a y column, and a z column. But notice that the way you could read this is basically, once it's in this form, it would tell you that 1x plus 0y plus 0z would give you 2, and that 0x plus 1y plus 0z would give you 1. So it's essentially giving you the answers, because if these are all zeros, it's telling you that 1x is 2, 1y is 1, and 1z is 6. Or in other words, x is 2, y is 1, and z is 6. So remember, I just made this up, but this is what reduced row echelon form looks like. I could try to define it, but it's easier just to look at a picture of it. When something's in reduced row echelon form, it essentially gives you what the answers are, because of the way these are, arranged. This is the x column. It's giving you the x's. This is the y's, and then this is giving you the z's. It's just telling you what their answers are. So now that we know what reduced row echelon form looks like, like I said, a human can turn a matrix into this. It's a bit complicated. And the problem is for this matrix, it's about the same amount of work to get reduced row echelon form for this that it is to solve this. Now, the good thing about this method is if you were to do it by hand, the more variables there are, the easier this method is compared to this method of doing elimination. But since we're not doing it by calculation at all, the really good news about this method is if you have a system of equations and you know how to write the matrix, you can have a calculator solve this and turn it into that reduced row echelon form. So that's what I want to show you. Now, I showed this larger matrix just to give you the point of what reduced row echelon form is, that it's ones on the diagonal, zeros everywhere else except this column. This column has the answers. Now, it might have a 0 or a 1 in it, but it's because they represent the answers. Over here, these have to be zeros and ones. All right? So let's look at the solutions to this thing now that we hopefully understand what I'm talking about. So how do you get the calculator to do all this for you? Well, it's going to be a bit of a pain to show you the calculator because I only got one hand while I'm doing all this. But I'm going to try to show you where the matrix menu is. Sorry, I was trying to get the calculator all set up. So here's the screen. Down, hopefully in the center of the screen, that under the math button, x to the negative 1. I'm going to try to move my finger so you can see it. So above this x to the negative 1 button, up there is math. I'm not sure how well you can see it in the video, but in above x to the negative 1, you'll see the word matrix. In this calculator, it's up here in blue because it's one of these fancy schmancy calculators. But basically, for all graphic calculators, it's in the same spot. Now, if you don't have a graphing calculator, on the homework, I will include a link to a website that will do the same thing that I'm going to show you. So let me show you it on the calculator. Like I said, the website if you don't have a graphing calculator, you can go to this website and it basically lets you enter all the same information that I'm about to show you. All right. So if you know where that matrix menu button is, I'm going to hit second in that button and you'll see 3 submenus. There's something called names. It'll list all the matrices. So basically they name all the matrices, matrix A, matrix B, matrix C. Now, if it's the first time you're ever doing this, you won't see this set of numbers here. They'll all be blank. But I've already entered a matrix into here. How do you enter a matrix or edit a matrix? Basically, once you enter one, you can't really delete it unless you clear out the calculator, but you never need to delete them. You can just always rewrite them. So if I go over to edit, I get that same list, but I want to hit enter because I'm going to basically take that matrix A and edit it. So I'm going to hit enter, and basically you're going to have to enter the size of the matrix. So what I have in mind is I cleared out the matrix that I had. I think when it starts you out, I'm not sure, I think it might say 1 by 1 or it might not have anything. You need to enter the size of the matrix you want. Since I turned this into a matrix, I need they do the rows by the column. So I need a 2 by 3 matrix. So what you're going to do is in the top where I have my cursor on that 1, I'm going to hit 2, enter, and then 3, enter. So I hit 2, enter, 3, enter. It will automatically make a 2 by 3 matrix. You can see that I can put 6 entries in. Now, when you go to put the entries in, it basically reads like a book. You're going to hit 4, and when you hit enter, I mean by read by book is it'll go from left to right, and then it'll go down a row, and it'll go left to right and down a row until you're done. So basically, I'm going to hit 4, enter, 3, enter, -1, enter. It'll automatically pop me down here. Then I'll hit 2, enter, 5, enter, 3, enter. Now, you can go to any entry you want. If you make a mistake, you can use the arrows, and you can go wherever you want. But if you just want to enter it really fast, you would read it like a book. Go left to right, and then top row is to second row, third row, and so on. So I'm going to enter it in because like I said I can't really show it on the screen and do it at the same time. So I'm going to hit 4, enter, 3, enter. And just to stop and show you, it's starting to enter them in, right? I have 4, 3, and now it wants that next entry. So I'm going to hit -1, enter, 2, enter, 5, enter, 3, enter. Once you have it in, the calculator automatically remembers. You don't have to save it or anything. This is now matrix A. What you need to do from here is once you enter it, you need to quit out. So you need to hit the second button and that mode button because quit's up there. So if I hit second and that, it puts me back out to the main screen. Now from the main screen, I want to put this matrix into reduced row echelon form. So I actually need to go back into that matrix menu. So here I am back in the matrix menu, and I need to find the command that I want. So if you go to the second menu, Math, there's a whole bunch of things you can do with a matrix. The list is really long. In fact, the list, I'm hitting the arrow, you can see how long this list is. It goes quite a ways, all the way down to E. Which thing do you want? You want selection B, which is off the screen until you scroll down. No, selection B is RREF. RREF stands for that reduced row echelon form. So it will change my matrix into this form so I can get the answers. All right, so once I'm on RREF, you hit enter, and it puts you back out to the main screen again, and now that's the command. You're basically telling the calculator, I want you to do reduced row echelon form, but you have to tell it what matrix you want. So you got to go back into the matrix menu one more time, and this time you can just, where it says names, you don't have to scroll over. You basically want to select that matrix A. Now, if you have other matrices, you can go down and select them. That's matrix A, so I basically want to select that one. So I'm going to hit enter. Once again, I go back out on the main screen. And now what this is telling the calculator is do reduced row echelon form to matrix A. So if I hit enter, matrix A has been put in reduced row echelon form. Now, it doesn't put the little line there, but remember what this means. I have ones on the diagonal, zeros in the other spots, and the last column then gives me the answer. This represents X, X equals -1, and this represents Y, Y equals 1. So the solution to that system of equations, if I know how to read this matrix, is that X is -1 and Y is 1. And notice that it took a little while to explain how to enter the calculator, but I didn't do any calculations. I didn't do anything. All I did was enter some numbers in and tell the calculator to do it. So this is a lot faster way of solving these if you know how to just enter it into a calculator. So let me do another one that's a little larger. Once again, this one I just made up, but let's do a 3-variable matrix. So here's a 3-variable system of equations. To solve this would take a while. If you did the assignment on solving 3-variable system, you had to pick 2 equations, eliminate a variable, pick 2 more equations, eliminate another variable, take those 2 equations, eliminate another variable, and then take that variable and then back substitute and back substitute again. It takes a while, and it's tedious, and you can make a mistake, and that's annoying. If I want to do it by a matrix, once again, I'm going to go into that matrix menu. Now, I would need an array that's got 3 rows and 4 columns. The 4th column is for these answers. When I go to enter it into the matrix, it's going to be a 3x4 matrix, so I'm going to go. Now, you can go back and edit A, or you can put in another matrix if you want. You can go down and edit B or edit C. I'm just going to edit A again because I don't need the old matrix I just made. So now I'm going to hit 3x4, because right now it's a 2x3 matrix, but if you just hit 3x4, it'll add the extra entries in it. So I hit 3 enter, 4 enter. Now no, it's a 3x4 matrix. Now I'm going to, once again, it's a little hard to do on screen, it's going to do it off screen. I'm just going to take all the coefficients and numbers, just make sure that these variables are all lined up. These are all X's, these are all Y's, these are all Z's, and these are all the answer numbers. So now I can just put them into the matrix. Just keep in mind anything that doesn't have a number on it really has a 1 on it. So I'm going to enter 1, -3, -2, -3, 3, 2, and so on. So let me do that right now. So I'm going to go through and put them all in. Just make sure as you put them in, you just check that you put them in correctly. So I'm going to do 1, -3, -2, -3, 3, 2, -1, 12, -1, -1, 4, and 3. So before I show you, I'm just going to verify that my numbers look good. That I entered everything correctly. All right, I believe I did. So you can see I just entered all the coefficients, all the numbers in order. So I went right along the top like a book, left to right, and then down a row each time. All right, so there it is. Once again, I don't need to save it. You can just exit out. So I'm going to hit quit and go back out to the main screen. From the main screen, I'm going to go back into that menu. I'm going to hit second in that matrix menu. When I'm back in the matrix menu, I'm going to go over to math because I want to do that command, that RREF. RREF is selection B. So I got to go down and do that. And then I'm back on the main screen again. I need to enter the matrix that I want to do this command to. So I'm going to hit second and the matrix menu one last time. So you got to keep going back into that menu. Under names, I'm just going to select matrix A. And so I'm commanding the calculator to do the reduced row echelon form to the matrix that I made out of this. Now, the matrix comes up, and there are my solutions. Remember how to read this. I got ones on the diagonal, zeros everywhere else. Basically, the 1 represents 1x, that represents 1y, and that represents 1z. So what are my answers? X is 4, y is 1, and z is 2. And notice, once again, I had to enter the numbers, but I didn't do any calculations. So I know the solutions to this. Basically, I know that x is 4, y is 1, and z is 2. And I didn't really have to do anything except to be careful and enter some numbers in the calculator. It did all the work for me. Notice how quickly that can solve a system of equations. Because like I said, it's taken me only as long as it is to do it because I got to explain it to you. But, however long it takes you to enter a bunch of numbers, you can do this in maybe 30 seconds and have the system solved where, a 3-variable system by hand, could take you 5 minutes, or if you get frustrated or do something wrong, could take you longer. All right? So that's solving systems of equations by calculator. Now, now that we know how to do this, if I were to just give you this, it wouldn't really be fair because, you're just having the calculator do all the work. So the major thing with this is to solve more difficult word problems. Now, before we go on, I'm going to do a couple word problems because basically you're going to have to set up the equations, but then you can do the solution through technology. Now, I mentioned if you don't have a graphing calculator, I will supply on the sheet, and the directions will be a website that will do this. Basically, the website will have the same options. When you go on the website, it'll ask you, it's like on the left side of the screen, it'll ask you to put in the rows and columns, and then it'll make a bunch of boxes for the entries. You can just put all the entries in, you hit the button that says to calculate, and right below it puts out the reduced row echelon form. So it will give you something that looks like this. So if you don't have a graphing calculator, go to the website that I provide you, and it'll do the same work. So you should be able to solve these and not have to do any of this by hand. All right, so what are the problems I'm going to give you? Because basically if I gave you these, your calculator would be done in 1 minute. So let's actually solve some more difficult problems with them. Things that we could solve by hand, but we wouldn't really want to. All right, so for you in the homework, the challenge is going to be setting up the correct system of equations. Once you set up the system of equations, the calculator will do all the work for you so long as you enter everything correctly. All right, so let's read these problems. I'm going to do one 2-variable problem and then one 3-variable problem. Remember, in a 2-variable problem, there should be enough information to set up 2 sets of equations. And for a 3-variable, you should be enough information to set up 3 sets of equations. So in this example, a student is selling 2 types of chocolate bars. And a way to really know you're getting a system of equations question is normally there's like 2 types or 3 types, and they give you all kinds of information about the types. So we have 2 different types of chocolate bars, regular and king size. The regular costs 60 cents. It's in terms of dollars, $0.6, but I'll just say 60 cents. It's 60 cents for a regular bar and 75 cents for the larger king size bar. Now they gotta give me some information. So they're giving me that the student sold a total of 177 bars. It doesn't tell me how many regular, how many king size. It just says all told of chocolate bars I sold, or this person sold 177. It also tells me that after they sold them, they got $118.80 in sales. So now they want to know how many of each type of chocolate bar was sold. All right, so the challenge here is to set up the system of equations. If we can do that, the calculator will do the rest for us because we can basically use a matrix to solve this entire thing. We can use a 2x3 matrix because it's going to have 2 variables. So let's talk about how we get the system of equations. So behind here, I got the work for the system. So I made my let statements. I'm laying X equal the regular number of regular chocolate bars, because that's one of the things I want to know. I want Y to be the number of king size bars, because that's the second thing that I want to know. I need to be able to set up two equations with it. So the bottom equation is actually the easier of the two. They told me that I sold a total of 177 bars of chocolate. So basically, since I have the number of regular and the number of king size, if I take the number of regular and add to the number of king size, I know that's got to come out as 177. The second equation, and usually when you do these, the second or even third equation, usually is an equation that has what I call weights on it. It basically scales the value. So what I mean by weights is regular chocolate bars, as far as cost goes, the regular chocolate bars are only 60 cents or 0.6 of a dollar. The king size chocolate bars are more expensive. They weigh more, or they have more cost to them. So they're 75 cents or 0.75. All right. So as I'm going through this, I want to make sure that I have the proper weights, or the proper multiples or scalings on them. So down here, the scalings are 1. Basically, one set of regular and one set of king size gives me 177. But basically, it's 60 cents times the number of regular bars I have will give me the amount that I brought in from regular bars. 75 cents times the number of king size bars will give me how much money I've brought in from king size bars. Combine them together, I get my total, $118.80. Now, I could solve this system by hand, but it's kind of annoying because it's got decimals in it. It's involving money, and this is probably not something you'd want to have to do by hand. So once again, this is why it's handy to put this into a matrix. What it's going to be able to do is get me the value of X and value of Y, because what I need is I need the number of regular king size bars not only to fit into this equation, but when I multiply them out, they got to come out to this exact amount. And to just look at that and know what those numbers are would be very difficult to guess. So what I'm going to do is enter this into a matrix right now. I'm going to make a 2x3 matrix, and I'm going to put in all of those coefficients in the order that I see them, and the numbers in the answer column. So I'll show you that in a moment. Keep in mind that these numbers are ones. So here's my matrix. I made a 2x3 matrix, and it has those entries. It has the 60 cents and the 75 cents and the $118.80, and then it has the 1, 1, and the 117. All right, so this matrix I'm going to do the reduced row echelon form to. So I showed you before. Once it gets a video, if you need to follow along or go back and see how to do it, I'm just going to quit out and put it all in. So I'm quitting out. I'm going back in the matrix menu to select the RREF and put that command on the main screen. And then I'm going back in the matrix menu one more time to select that matrix. So I did everything I showed you earlier. There's RREF of matrix A. And here are the solutions. So how does it come out? Well, notice it's in reduced row echelon form. So the top row is telling me, well, the 1 in the top is telling me that X is 93, and the 1 on the bottom is in the Y position. It's telling me that Y is 84. So my answers are 93 and 84. Basically, this person sold 93 regular bars and sold 84 king-size bars of chocolate. And if you want to check those, you don't have to so long as you put everything in the calculator correctly. But if you wanted to check them, you'd see that if you put the X's in and the Y's in, let me see, 93 and 84, they'll come out to fulfill both of these equations. All right, let's look at a 3-variable one, and then hopefully you can do this on your own. So the 3-variable one's a little more complicated because it's got an extra set of information in it. So similar problem to the other one, it's just now I've got, instead of 2 types of candy bars, I've got 3 types of coffee. So I got 3 sizes of coffee. I'm going to call them small, medium, and large, but it's important I have their volumes because that's a set of information that I need. So the small coffee is 300 milliliters. The medium coffee is 500 milliliters, and then the large coffee is 800 milliliters. They also give me the cost of them. So the small coffee costs $2.25, the medium coffee costs $3.25, and the large coffee costs $5.75. And then finally, they give me that last piece of information that the total number of coffees they sold for, I don't know, we'll say for the day, was 37 coffees. So now they're going to give me the totals of everything. So not only did they sell 37 coffees, but the total volume of coffee sold was 19,100 milliliters. And then the total sales they collected was 133.25. So they've given me size information, they've given me cost information, and then they've given me like total units information. So I have 3 different size coffees, but since I have 3 different sets of information, I can make 3 equations. And if I have 3 equations and 3 variables, I can solve for what this is, so long as I can set up the equation. So I'm going to show you the equation setup on the board in the back. Let me just switch out the other one that I was doing. And then this system of equations would be pretty difficult to solve if I were doing it by hand. So this is where the calculator is going to be really handy. Or once again, if you don't have the calculator, go to the website that I gave. And once again, it will solve the system for you, so long as you enter it carefully enough. All right, so let's look at how it's set up as a system. So once again, I made my let statements. I have X is the number of small coffees, Y is the number of medium coffees, and Z is the number of large coffees. With that information, I just need to scale everything appropriately. The one at the bottom is the simple equation. Basically, if I add all the coffees together, I know there's a total of 37 coffees that were sold. If I want to get the other piece of information, I need to use like the weights of the thing. So basically, there's 2 ways they're weighing out the coffees. One of them is by cost. So there's a cost for each set of coffees that come out to a total cost. But they can also be weighed by how much volume they have. These are the volumes. So notice that, if I want the total volume, I need 300 milliliters times the small, and so on, 500 times the medium. If I want the cost, I need 225 times the small, 325 times the medium, and so on. So if you could set up these equations, the top equation is based on the total volume, which came out as 19,100. The second equation is based on cost, which total cost was 133.25, or basically what they're bringing in for sales. And then the last one is just as total units, as these things not being weighed just as individual units. All right. So those are the 3 the system of equations. I need the 3 equations. What I want to do now is enter it into a matrix. So let me get it up where I have the matrix menu ready to go, and I'm going to enter these. So you're going to make a 3x4 matrix. Keep in mind when you're making the matrix, you want to count these as 1. So I'm basically just going to enter this array of numbers, 300, 500, 800, so on. I believe I have that done here, so let me just verify these numbers, because I really don't want to have to edit the video or record it again. So looks like it's decent. So I have all the correct numbers in. So with those correct numbers, I just need to get the reduced row echelon form on this thing. All right, so I need reduced row echelon form. So I'm going to quit out of this. And I'm going to enter the reduced row echelon form. And then here it is. So notice once again how to read this. The 1 in the top left corner is representing X, so X is 12. The 1 in the middle is representing Y, Y is 15. And then the 1 on the bottom right is representing Z, which is 10. So now if I go back, my answers are X is 12, Y is 15, Z is 10. What did they mean in context? Well, X was the number of small coffees. So I have 12 small coffees that I sold, or that they sold, 15 medium coffees, and then 10 large coffees. So notice that so long as you can enter these into the calculator or that website I gave you, these are easy to get the answers to with technology. trying to solve this by hand would not be fun. Having to eliminate all this and having to take two equations and two more equations and eliminate and get another set of equations, eliminate that, and back substitute, and all the mistakes that you could make. The calculator is very good at doing this. It does all that work very quickly and very accurately, so long as you enter things correctly. So the biggest thing for you is to, number one, make sure you set up your equation correctly, and number two, make sure that you check that all the numbers are good. Now, like I was saying, as I've been giving you integer solutions, you will have integer solutions on your worksheet that I'm giving you. So if you come up with decimals, now once again, it doesn't mean that in real life and other situations you can get decimal answers. I'm just not giving you decimal answers, once again, to just make it so you can tell if you did it right, because chances are, if you did it wrong, you'll know it because you'll get weird decimal answers. Since I made the answers come out as integers, you'll know that you set the equations up right and that you entered them in the calculator correctly. All right, so hopefully this makes sense, how to use the calculator to solve these. And like I said, it saves a lot of work. All these problems, I said, I'm explaining them on a video, but if I was just doing these with my knowledge of what I know in a calculator, I could have solved all these problems probably in a minute or two, where if I were to do them by hand, it would take me a long time, and that's if I didn't make any mistakes, and I'm the teacher. So for you, you don't want to have to do all this stuff by hand if you don't have to. I would also keep in mind that in the future now, if you take an SAT or a college entrance exam or anything and you have a calculator available, systems of equations are very easy to solve if you know how to ask the calculator how to do it. So this lesson is not just useful for future college courses if you happen to do them, but any kind of standardized math tests that you may do in the future. Keep this in the back of your head that if you run into systems of equations, which are typically difficult to solve, you now have this matrix method, and you can have the calculator completely, sort of rip the problems off for you, right? They become extremely easy to do because you don't have to do any of the work, all right? So this was about, once again, about what a matrix is and how to use it to solve a system of equations. And once again, do it in your calculator. If you don't have a calculator, go to that website that's provided on the top of the homework. It should hopefully be straightforward because, like I said, you go to if you'll see on the left side of the screen, you can enter in the size, enter in the values, and it lets you like reset the matrix or clear the matrix if you want. There's a little button below it that says calculate, and I don't even think you need to scroll down, but depending on your screen size, you might have to scroll down a little bit, and you'll see the reduced row echelon form. All right, so give the homework a try, and hopefully the technology makes it easier for you. All right, until next time.